Hello all. In the chapter Coal and Petroleum, we learned about natural fuels. In our daily life, we use a number of fuels. In villages, people use wood to prepare food. In cities, CNG and LPG is used. In automobiles, petrol and diesel is used. If you look carefully, you can see that some materials burn with flame and some without flame. If we light a candle, we can see a flame there. But if we burn coal, it will burn without a flame. It will only give away heat and light. The process in which a substance reacts with atmospheric oxygen to give off heat is called combustion. The substance which undergo combustion is termed as fuel. There are two types of fuels. As we said earlier, some will give flame and some burn without flame. If we burn wood, we can see flame there. Flame and heat is there. But if we burn charcoal, only heat and light is produced. There are two types of substances, combustible substances and non-combustible substances. Combustible substance burn in presence of oxygen. Non-combustible won't burn in presence of oxygen. Examples of combustible substance are wood, petrol, diesel, charcoal. Non-combustible substances are stone and glass. Air is necessary for combustion. Let's do one experiment. Place a lighted candle and on either side of the candle place two wooden rods. Over that wooden rod place one chimney. This chimney is open on both ends so that air can enter from the bottom part and from the top part. Nothing will happen to the flame as enough air is there. Then remove the rods and place the chimney over the table so that only air enter through the upper side. Then the flames start to flicker. It will produce fumes also. Now place a glass plate over the chimney. This will prevent the entry of air. Now the flame will go off due to the absence of air. From this experiment, we can conclude that air is necessary for combustion. If a person's cloth catches fire, what we can do, cover that person with a blanket so that the blanket can cut the air supply and we can save the person. You might be familiar with forest fires. You might have heard about forest fires. These forest fires happens due to the sudden combustion of dry leaves in extreme summer. This forest fire is very difficult to control because in the presence of wind or in the presence of oxygen, this fire will spread. It will be very difficult to control the forest fires. Now, ignition temperature. Substances won't catch fire just like that. They need to reach certain temperature to catch fire. The lowest temperature at which a substance catch fire is the ignition temperature of that substance. For example, paper. Paper won't catch fire in room temperature. But if we place a burning matchstick near to it, that will provide some heat to the paper and it will cross the ignition temperature and catches fire. Like that matchstick, the rubbing of matchstick, that rubbing friction will provide some heat and it will cross the ignition temperature and the matchstick catch fire. We can burn a paper with the matchstick but not wood because the ignition temperature of wood is higher than that of paper. To burn wood, what we will do? Pour some kerosene over the wood and place a burning matchstick over it. The kerosene catches fire quickly and that will provide some heat to the wood. It will cross the ignition temperature and catch fire. In room temperature, kerosene and oil also don't catch fire. If we provide heat, then only it will catch fire. Let's see one experiment. Take two paper cups and pour a 50 ml of water into one of the cups. Here water is there. And place two cups simultaneously over the candle flame. What happens? The empty paper cup will burn quickly. It will catch fire quickly, but not the cup which holding the water. What happens is the empty cup will reach the ignition temperature quickly and catch fire. But in the case of the paper holding water, the heat provided will be transferred to water through conduction and water becomes hot. If we continue heating, we can even boil the water, but the paper won't catch fire as it won't reach the ignition temperature due to the presence of water. Now, inflammable substances. You might have seen the tankers which are used to transport petrol. It is written highly inflammable on the sides of tankers. Substances which have very low ignition temperature and that catches fire very easily are called inflammable substances. Now, control fire. There are three essential components to catch fire. One is fuel, air and ignition temperature. If we cut off either air or ignition temperature, we can prevent fire. If we bring down the ignition temperature, then we can extinguish the fire. If we cut the air supply, then also we can extinguish the fire. You might have heard of fires on buildings. Then fire force will come and spray some water. This water removes heat as it absorbs heat and transforms to water vapors. This will bring down the ignition temperature of that materials and also water cut down the air supply. That will help to prevent the fire. But water is not used to extinguish the fire on electrical appliances as water is a conductor of electricity and it is harmful for the firefighters. So what we will do, we will use fire extinguishers. These fire extinguishers are devices used to extinguish fires in emergency situations. You might have seen this in your schools or offices. It contains carbon dioxide. Fire extinguishers contain carbon dioxide in it. This carbon dioxide covers the fire like a blanket and air supply is cut. That will prevent the fire from spreading. And also this carbon dioxide expands and cools down. That will bring down the ignition temperature of that fuel. That will also prevent the spreading of fire. Now, there are three types of combustion. One is a rapid combustion. When a substance burns rapidly and produces heat and light, that is called rapid combustion, like in LPG gas stove. If we switch on the gas and bring a burning matchstick near to it, it will catch fire quickly. That is a rapid combustion. Spontaneous combustion. As we said earlier, spontaneous combustion of dry leaves will cause the forest fires. If a material suddenly bursts into flame without any help of external heat, that is spontaneous combustion. And one more example is phosphorus. Like we learned in metals and non-metals, phosphorus when come in contact with air, it will burst into fires. So to prevent this, we are storing phosphorus in water. Another one is explosion. Sudden reaction in which a large amount of heat, light and sound is evolved. That is called explosion. Example is crackers. Now flame. Some substances burn with flame and some without flame. The substances which are vaporized on burning will produce flame. Like candle. We all know that candle is made of wax and wax is vaporizing on burning. That's why candle produces a flame. And like LPG gas stove, we can see a blue flame here. Here we can see a blue flame, here we can see a yellow flame. Why? What is the difference? When a candle is lighted, the air around it will expand due to the heat. That will cause a low oxygen supply. Because of this low oxygen supply, this flame is yellow. And here it is blue because there is sufficient oxygen supply. Let's move on to the zones of candle flame. The flame contains three parts. One is the innermost zone, that is the darker area, it is the least hot, it contains unburned wax vapors. Then middle area, it is the brightest zone, it contains unburned carbon particles. And then the outermost zone, it is the hottest zone, which is blue in color. And due to the plenty of air, full combustion of fuel takes place. That's why it is the hottest zone. Now to study more about the zones of a flame, let's do some experiments. Glass tube experiment. Take a lighted candle and introduce one glass tube into the innermost zone. Then place a lighted matchstick on the other side of the glass tube. Then we can see a flame in this side. This is because the unburned wax vapors will enter the glass tube and it will catch fire at this end. Then glass plate experiment. Take a lighted candle, place a clean glass plate over the middle zone. Keep that plate over the flame for some time. After some time, we can see a black ring over the plate. This black ring is produced due to the presence of unburnt carbon particles which is present in the middle zone. Another one is copper wire experiment. Light a candle and place a copper wire over the outermost zone. Then it is the hottest zone. What happens is after some time, this copper wire turned red hot. Now, good fuel. What is a fuel? Fuel gives heat on burning. There are some criteria for a good fuel. Like it should be least expensive, readily available. Fuel should burn easily. Fuel should produce large amount of heat and it should not leave behind any undesirable substances. Moving on to calorific value. If we try to boil 1 liter of water with different fuels, the time taken to boil water will be different. If we try to boil water over LPG and if we try to boil water over burning wood, the time taken for both will be different. Then the amount of heat energy produced on complete combustion of 1 kilogram of fuel, it is termed as calorific value. It is expressed in kilojoules per kilogram. The calorific value of cow dung is least and calorific value of LPG is the highest. Let's move on to harmful effects of burning fuel. Burning of wood produces smoke. This smoke will lead to many respiratory disorders and also cutting trees will lead to deforestation. Incomplete burning of carbon fuels cause a respiratory disease. Incomplete burning of these fuels give rise to carbon monoxide. This carbon monoxide is a very poisonous gas. It can kill the people who are sleeping in the room in which the fuel is burning. Global warming. This incomplete burning of fuels will also give rise to carbon dioxide. This carbon dioxide will trap the heat radiations reflected back from the earth. That will lead to the increase in average temperature of earth, that is global warming. This global warming will result in melting of glaciers and that will increase the sea level. This will result in floods in coastal areas. Now acid rain. Burning of petrol and other kinds of fuels will produce some oxides of nitrogen. When oxides of nitrogen combine with rainwater, that will produce nitric acid. This nitric acid falls along with rain. That will cause harmful effects to crops and also buildings. Let's do a recap. In this video, we learned about combustion, what are the three essential components for combustion, how we can control a fire, and what are the harmful effects of burning fuels. Thank you.